Good morning, students. In the today's session, we'll learn about internet working, okay, and also tunneling and fragmentation. What is mean by this internet working here? What is mean by internet working means whenever in the real world scenario, network under the same administrations are scattered geographically, okay. Here, whenever if we have like this internet working means like if we have different networks of same kind as well as of different kinds, but routing between the two different networks is called as the internet working, okay. This is the main important point. Routing between the two networks is called internet working. In this internet working, here we have the different types of routers have knowledge of say each other's address as well as addresses beyond them, okay. They can be statically configured, go on to the different networks, and they can also learn by using the internet working routing protocol, okay. And main important point here is the routing between the two networks is called internet working, okay. And next here, like here, the routing between the two systems under the same is called the routing between the different networks is called internet working, okay. And here the routing protocols which are used within the organization or administration are called interior gateway protocols or IGP. Routing protocols in which are used within an organization or administration is called the gateway protocols, okay. It means the routing protocols under the same organization or administration is called as the gateway protocols, okay. And RIP, OSF, okay, OSPF, these are all the examples of these gateway protocols, okay. And now here the routing between the different organizations or administrations is called exterior gateway protocols. Here, the main important point here you have to understand is routing protocols. The routing between the single organization is called interior gateway protocols, and the routing between the different organization is called as the exterior gateway protocols. Here, the examples for the interior gateway protocols are the RIP, OSPF, okay? And the examples for this exterior gateway protocols are the border gateway protocols, okay? And now here, what is mean by tunnel? If there are two geographically separated networks which want to communicate with each other, okay, they may deploy a dedicated line between to pass the data through the intermediate networks. It is called tunneling. Here, in this tunneling, what we have, it is a mechanism by which two or more same networks can communicate with each other, okay, by passing this intermediate network, okay. And tunneling is configured at both the ends, okay. Whenever if we have tunneling, we have a virtual direct link will be there, okay. And now when the data enters from the one end of the tunnel, it is tagged. This tagged data is then routed inside the intermediate or transmit network to reach the other end of the tunnel, okay. And the both ends seem if they are directly connected, and tagging makes the data travel through the transmit network without any modifications, okay. Now we have learned with the what is meant by internet working as well as what is meant by tunneling, and we'll work with what is meant by packet fragmentation. Here, the most Ethernet segments have their maximum transmission unit, okay. That means it is fixed for only 1500 bytes, okay. A data packet can have the packet length depending upon the applications, okay. Devices in the transit path also have their hardware as well as the software capabilities, okay, which tell what amount of data the device can handle and what size of packet it can able to process, okay. These two are very important, okay. And in this packet transmission, we will be fixed for 1500 bytes, okay. And if the data packet is less than or equal to the size of packet, okay, then the network can handle it is processed neutrally, okay. And if the packet is larger, it is broken down into small pieces, okay, then it is going to be fragmented. This is called as a fragmentation, okay. And each fragment contains the same destination and the source address and routed through the transit path easily. At the receiving end, it is going to be assembled once again. Okay. And what is meant by this congestion? A state occurring in network layer when the message traffic is so high that it slows down the network response time. Okay. And the effects of congestion are, as delay increases, the performance will decrease. Okay. As delay increases, retransmission occurs, making the situation worse. Okay. And in the today's session only, we'll learn about what is meant by this leaky bucket algorithm. Okay. Let's see the working condition of the leaky bucket algorithm. Here we have a host computer. Okay. Here, like the unregulated packet flow, the packet holding the packets, and regulated packet flow. Okay. That means here, if we have the bucket holding the packets, it is going to transmit the packets one of the other in a proper form. Okay. Now, the leaky bucket algorithm may control the total amount and the rate of traffic sent to the network. Okay. Let us imagine a bucket is having a small hole at the bottom where the rate at which the water is poured, okay, into the bucket is not constant and can vary, but it leaks the bucket at a constant rate because the hole is a constant. It is going to constantly, it is going to leak the data one after the other. In the next step, what we have, up to water is present in the bucket, the rate at which the bucket leaks, okay, the water leaks does not depend on the rate at which the water is input to the bucket because it is the standard value will be there. Okay. And in the step 3, if the bucket is full, additional water that enters into the bucket that splits over the sides and is lost. Okay. And at the step 4, does the same concept apply to the packets in the network? Consider the data is coming from the sources at various speeds. Suppose that a source sends data at 10 megabits per second for 4 seconds. Okay. Then there is no data for 3 seconds. The source again transmits the data at a rate of 8 megabits per second for 2 seconds. Thus, in time span of 8 seconds, 68 MB data has been transmitted. That's why if a leaky bucket algorithm is used, the data flow will be 8 megabits per second for 9 seconds. That's a constant flow will be maintained. Okay. All the best.